Hello, everyone. Welcome to the August edition of the Azure Functions Community Stand-Up. Today, I'm joined by Sonia, who's also a PM on the Azure Functions team. And we have quite a few updates to give you. Some are just recent news that we announced in last month in September. But then Sonia will go deeper into Java updates. Sonia, if you could go to the next slide, please. Here we go. So these are a lot of announcements that we had at the end of September that we thought it would be good to call out for you. On the languages area, we announced the GA of the new programming model for Node.js, the V4 programming model, sorry. And we had a live stream in May, if you go back to our list of live streams, where we walked through all of the updates there, and there's quite a lot of great improvements if you're a Node developer and are using Azure Functions. Staying in the Node section, we also announced support for Node.js 20 in public preview. And then moving on to Python, we announced the 3.11 support for Python and Azure Functions. Now it's in GA. And also, as we have new versions of languages that we support in Azure Functions, we also deprecate them as the community deprecates the support for the languages. So just a reminder that next year in October, we will have the end of support for Python 3.8. Of course, given this is the languages section, we have quite a few Java updates, so Sonia will cover those soon. And moving on to triggers and bindings, we finally announced the public preview of the Azure Functions extension for Dapper. This is quite an interesting one, especially if you are looking at running Azure Functions on container apps and you want to take advantage of other microservices that you might be sharing container apps environments with. Now you can write Azure Functions, use the Dapper extension, and things like service discovery and other features of Dapper together with the other microservices that you might be writing and hosting on the same environment. So please do check that out. And then finally, 2 reminders of things that will be out of support in the future. The first one is the V3 extent of the Azure Cosmos DB extension. So please upgrade to the V4, the latest and greatest, by next year, by August next year. And then finally, we announced the 3-year deprecation of the V1 version of the Azure Functions host and runtime. So you still have a little bit of time there, but it's a good time to start looking at how you can migrate your older V1 Azure Functions to the V4 of the host and runtime. With that, those are the updates from September, and I'll hand it over to Sonia to talk us through all of the updates related to Java Functions from the past few months. Take it away, Sonia. Thank you.
Thanks, Thiago. Hello, everyone. I'm Sonia Kulkarni. I am a Senior PM Manager in the Azure Functions team. My team is primarily responsible for the growth of languages on the platform, the non-traditional languages, so Java, Python, Node, and PowerShell, and also the client tooling experiences that developers use when they code or write Azure Functions, so like core tools, AZCLI, VS Code, etc. So I am really excited to be here on the community stand-up today, as we are going to talk about all the things that we did in the Java world to support our customers if using Java functions. Okay, so looking back a little bit, last December, we announced 2 big features. They were made generally available. So Azure Functions support for Java 17, which is currently the latest version on the platform, and the durable function support for Java as well. Both of these were like top asks from our customers, and we also always want to support the latest and the greatest language versions on the platform. And it is really heartening to see the growth that we've seen for the usage of these features. So starting like since this was published in December, from January to October now, like we've seen a really good trend for the usage of durable Java as well as Java 17. So what's new in 2023? There are a couple of, again, big investments that we've done and announced GA of several features. And I'm going to go into details of most of these today. So the first one was dependency injection hooks. We announced GA for that. The other was application insights distributed tracing. This is actually a really powerful one, as it is strengthening the monitoring story we have for Java functions today. I'll go into more detail and show you a demo there in the subsequent slides. Azure SQL bindings also went GA. And beyond that, we made some improvements and enhancements in the durable functions experience, post GA in December. And we also made some really, really dramatic cold start improvements, which I'm really excited to share today. Okay, so let's dive into dependency injection. As most of you might already know, this software design pattern is a technique to achieve inversion of control between classes and their dependencies, right? And the main goal is to be able to write code that's more testable, modular, and maintainable. So Java Azure Functions now provides a hook to the very popular DI frameworks like Spring, Quarkus, Dagger, etc. And the way we do that is the SPI contains an interface, function instance injector, which needs to be implemented in your code. And that should return an instance of the functions class. So now any new function invocations that now happen will be invoked on this instance, and they will interact with the functions host runtime. We have documented it really well, so I will encourage you to look at the documentation. Let me just show it here. And this also it talks about how you use it in Java functions, and it also has a link to a repository which has samples. Um, One thing I would like to point out here is the difference in how you would use it for, say, Spring app versus a Dagger function. And this shows both, but let me show you how easy it is to do it for Spring. So in Spring, what you would do is with Spring apps, in the POM file, you just add a dependency for your in within your function app for function adapter Azure, and then in your source code, you would just auto wire. Let me show you here. So hello is the function class, right? And here you would auto wire it in the handler. You would use dependency injection like this. So it's just with that annotation, right? So it's pretty straightforward to use it with Spring apps. But whereas with, like, you would see the Dagger example, you will actually have to write the code files yourself and implement the interface and such. But yeah, do feel free to check that out. Moving on, so this is a really exciting update I would like to share. So application insights, if you have used functions before, as you might know, this resource is created automatically when you create a new function app. And that's where we are collecting the logs, metrics, and everything that is being logged in the different components of the platform is all going to the application insights workspace. So we already had a version of distributed tracing available to customers for the different languages that we support. So what's new? So here, this is what makes it very powerful. There are three new things that we have now included with the enhanced flow or the recommended flow. So if you can see in the screenshot down below, if I can configure my application insights collection level to recommended, what we had before from a functionality perspective was the basic flow. And I'm going to show you the difference between the two flows. But the three main differences with the recommended flow are the user code, and if the user code in the function app is actually calling out to any libraries or using libraries or using SDKs, that those calls were not shown, were not visible to the customer before. But now with the recommended flow, we are able to collect the telemetry for popular libraries and Azure SDKs. So this gives it a lot more This gives developers a lot more visibility into where, how things are working, where calls are being made, if there are errors or failures, to debug them, to diagnose them. So it just is really powerful from that sense. The second thing is the ability to add custom telemetry. So you can define your own telemetry in the function app code, and you will be able to view the data that has been collected on that front as well. And the third thing is the profiler. We know that Java developers specifically are interested in learning more about, how their memory or CPU is being used, or if there is how they can optimize their functions better. So now with the profiler feature available, they are able to get the JFR file, and then from there they are able to, better manage their apps. So with that, let me quickly show you the things that we are already collecting, like in the auto collection. So you can see here, these are all the requests. These are the dependencies that are currently being auto collected, which didn't exist in the basic flow again. JDBC, then there are specific metrics, these libraries, all of this is currently, and this is all documented. So you can take a look. But all of this is already now auto collected with the recommended flow. And there is also a way how you would define your custom telemetry. So you can always look at the docs and try to repro or figure it out. But I'm going to show you a demo. So I have here sample code. This is very simple sample code. This is basically an HTTP triggered function. It is using Cosmos DB as an output binding. And all it's doing is it's parsing the query parameters, and then it's creating a custom metric here of the name with the name entry counter. And there is a VM I have which is running MySQL. So it is insert using the driver to insert into that SQL database. And then this is where it's doing the insert. And finally, it's also adding that entry into the Cosmos DB. Now, this it's doing using the output binding. So this is the additional piece that it's doing, which is using, a library in my code itself. Okay, so now I have created two different function apps. One is with the basic flow, and the other one is with the recommended flow. I have deployed this code to both those apps. And let me just show you here. So if you go to Insights, oh, excuse me. So this is the resource group. Yep. So if I go to my function app, and in application insights here, as you can see, the collection level is configured to be basic, right? So let me now show you the app insights view for the basic flow, which already exists, but I just want to show you so we can compare it with what now exists. So this is how the app map view looks like. As you can see now, it's showing in the last hour that no calls were made. There is one instance, and it is calling out, like, this is the output binding Azure Cosmos DB that we had configured in code. Let's go and invoke this function. So let's go to the function app, and let's look at the functions here, the HTTP function that we have created. And get function URL, copy that, and I'm going to invoke it with name equals Adam. Okay, so I've just invoked the app. Now let's go back. It will take a little bit of time for the logs to show up, but in the meanwhile, let's go to App Insights. And here I will go to App Map View. Okay, so it's still taking a little bit of time for it to show the calls. In the meanwhile, what I'm going to do is also trigger the other app. This app now is configured with, like we have discussed before. This is where the distributed tracing has been enabled, like the app map flow. Let me go back. the recommended flow is enabled or configured uh, for this app. So let me go to, this is the app map view, which is currently only showing Cosmos DB. But let me go back to the resource group. Java distributed tracing. I can go to the function app. Okay, and just showing you here that we have configured the recommended flow on this app. Now we will also make a call here. Okay, we've made a call here as well. Back. And now look at the app map view here. So it will take a couple of seconds. This is, so just to re-enumerate, this is the Java distributed tracing, which is the function app which has the recommended flow on, and we have triggered this function app, triggered the function in this app, and we are looking at the app map view. The other one is where the distributed tracing is at the basic collection level, and we are looking at the app map view here. So let's see if this actually is now showing. Yes, it is showing one call, right? It was showing 0 call. So there is one instance and one call which we just triggered, and this was 12 before, so it's showing now, yes, that it is calling out to Cosmos DB. And if we want to know more details, all of this exists. But yeah, this is how you would look at investigate performance, or if you want to, if there are errors, it would also show you that. Now looking at this one, it's the same code, mind you. So let's refresh this and see if this is showing up. See the difference here? So it is now showing one call, but it is showing this call that has been made to the MySQL, which is running on a VM as well. That's the power that the recommended flow now shows, right? So one of the features, like we discussed, is if the app code itself has is using Azure SDKs or libraries, external dependencies, then it is auto collecting the telemetry there, and with the app map view you are able to see that and in real time, and also monitor the errors and performance at that point. That was one. The second one we talked about was custom metrics. So let me show you how you would see that. So let's go to the metrics for this app. Here I would pick the metric namespace, and here I should be able to see the entry count, that entry counter that we had. It's still loading. Okay, and let me say sum. Okay, so this is actually calling it over a couple of hours, last 24 hours, in fact. So if I were to see, I think right now this is showing me that the code was invoked 3 times in the last 24 hours, and that's what it's showing. But you are able to see the specific custom telemetry that you defined in your code again on this view. And finally, the third thing is profilers. So I'm going to show you that. If you go into performance, there is a section for the profiler. And here you would see, so I actually did this takes about 20 minutes. If I click profile now, and it's going to profile my app, so it'll tell you that it is going to take, oh, this is okay. Last time it was longer than this, but yeah, so just so I didn't want to wait. This is, while this continues, there I have already generated a file yesterday when I was testing this out. So yeah, the JFR file is, you can further use it to figure out what's wrong, or where, how you can improve or optimize on performance. So all those three things are really powerful. And it really helps customers and developers to know what's what in their app. And the visualizations that we just looked at, is the app map, where you could get a complete view of how the systems are interacting. You could get data on performance and errors, and more data, so you can diagnose issues and reliability and performance issues more accurately and quicker. The next one that we looked at was custometrics. And then if you go to the performance, you see the profiler. So all these visualizations are available to you if you use the recommended, if you configure the collection level to be recommended on the App Insights instance created with your function app. So you one, the cherry on top, I would say, is the cold start. So if you use this feature sometime before February, the cold start was 9 seconds. But right after February, we've been working to reduce the cold start. If you use the recommended flow, it's now less than 1 second. The cold start, as you saw, we invoked the function, and then we saw in the app map view already the logs coming through. So this is really, really powerful for customers and developers. So do use it and let us know how you feel. There is code that will be, like, if you want to just try it out with the same code I have, that will be available in the Java documentation samples. That will be published a little bit later this week or next week. Yeah, that's on this feature. Moving on, durable functions, I won't go into too much detail. As we talked about earlier, we GA'd it in December, and then there were customers asking for a little bit more, and we wanted to make sure we had feature parity with the durable implementation across like .NET and other languages. So there were a couple of enhancements that we did, like mainly supporting things right from the SDK, and the different application patterns. And if you wanted to get started, if you haven't used durable before, then this is a really good documentation for the different patterns that you can use with durable. So this is language agnostic, the patterns that can be used. There are like 6 or 7 patterns that you can use. And then if you wanted to specifically look at durable Java, then we also have how to get started with your first durable function in Java. So we have 3 different ways: so manual setup, Maven, and VS Code. So feel free to try it out. Now this, if you are interested in knowing what's happening in this space, the GitHub repo is a great place, and you can also create your issues there if you are having any challenges, or monitor like what's happening, what's new. Okay, moving on. Cold start. Last but not the least, this is again like really something we feel is going to really delight our customers and developers. Before January of this year, before we did any cold start optimization, as you can see, the 50 percentile number was 1.2 seconds, but it was reduced by 50% as of today, like as of October, and it's now 0.6%. Sorry, 0.64 seconds. And that is really powerful. Also, on the P99 percentile number was before 6.9 seconds, and now it was reduced by 75%, making it 1.7 seconds, which is again really, really powerful. So if this was one of the reasons why you were kind of hesitant on using Azure Functions Java, or you were just trying to POC it out, or you were using it, but you were like, why I really want the cold start to be low, then this is the cherry on top today. The takeaway: the cold start has really drastically improved, from like up to 75% from where if you used it before. So with that, we have really good documentation. If you want to start writing your production code with Java Azure Functions, we have the quick starts. Let me just quickly show you the 3 good sections or pieces of documentation. So this is the base homepage for functions, and in here you have a quick start. So you have a Java quick start with any of the tooling of your choice that you can start writing your first function in. So this is one. The other one is the developer guide, which is under languages, and you can see Java developer guide here, which talks about best practices, and it also has like other things like runtime availability support, configure your JVM, your dependency injection that we just saw. And finally, the samples that I was talking about. So here, if you go into samples, Azure samples, and you have Java. So these are all the samples we have currently for Java. These are the repos, but then the things that we looked at today, dependency injection, distributed tracing, those samples will also be published here, either in one of the existing repos or as new samples altogether. But just wanted to show you, this is what like all the samples we have today for Java functions. Okay, with that, that's the end of my presentation. Thank you so much, Thiago, for having me. I am really excited for what's to come for Java Azure Functions. We really are trying to meet customers where they are and listening to what's important to them and prioritizing their top asks. And we are delighted to see it reflect back in our usage and our numbers and the feedback that you guys have been giving us. So thank you so much.
Thank you, Sonia. Yeah, it was a great overview of the latest updates to Java. I'm very excited about both the end-to-end telemetry updates that is looking really nice, and also cold start improvements, of course, given that we get a lot of feedback on cold start for Azure Functions. So there's an overall improvements that we're making across the platform, but also in specific languages. And hopefully we'll share more about that in the future, as well as in the form of blog posts. And for anybody watching this video, either live or watching the recording later, look out for the apps on Azure blog post, where we're going to share all of the links and information of what Sonia shared today in an upcoming blog post as well. With that, that's it for us. We'll see you next month. Thanks again, Sonia.
Thank you. Thanks, Thiago. Thank you, everyone.
Bye.
Bye.